Alright. Hey, my name is Dave. Thanks for coming into the Science Museum with your children. And you guys are from? What grade are you guys in?
Fifth, sixth.
Fifth, sixth. You guys start doing any chemistry yet?
No.
You will! At some point in your education career. And you know what? Even if you don't, it's good to have some basic chemistry in your head, all right, on how things work. Because chemistry, of course, is going on in our bodies. It's going on in all kinds of products we use today. So you can become an informed citizen when you become adults and you got to buy stuff and do stuff more on your own. You might know a little bit about chemistry and it can help you out. Right? Let's take about 30 minutes or so. Got any questions? Sing out.
Are we going to learn how to make a rocket from nitrogen peroxide and sugar?
No, we're not going to do rockets with nitrogen
peroxide. No, not nitrogen peroxide.
But I am going to go over a few basic chemical reactions you may or may not be familiar with, okay?
No.
All right? And I'll point out now, and I'll definitely point out at the end, hey, what am I wearing here?
Apron, glasses.
And particularly glasses. Now, I'm going to be doing things here. I like to have a little fun when I do my demonstrations. But messing around with chemicals on your own can, one, get yourself really hurt, if not killed, and two, especially these days, get yourself in serious trouble if you have things that are explosive. So, whenever you're doing any kind of chemistry with chemicals, make sure you're with somebody who knows what they're doing, be perfectly in school, okay? And you take the appropriate safety precautions. Adults all the time don't read directions and do things and get themselves in a precarious situation. Okay, so we're going to go over what combustion is, pH, a little redox reaction, catalyst, endothermic, exothermic. All right, let's start out with combustion. All right, I need a light master general over there. Gentlemen, stay. All you got to do is hit that button right behind you on that panel there, sir. All right, so I'm going to start out with a little combustion.
Wow, we're lighting the candle.
Voila! Combustion. What's going on?
You just lit a candle. You just lit a candle.
All right. What do you see before you?
Light flame.
A flame. It's one of the end results of combustion. What do you need for a flame to burn? Raise your hand. What do you got, buddy?
Oxygen.
Oxygen, you say. Where do you find oxygen around here?
Everywhere.
All right, it's 20 or 21% of what you're breathing. All right, so you need some oxygen. What else do you need for a flame to burn? Yeah.
Something flammable.
Something to burn. You need some fuel. And you need one other thing unless you have spontaneous combustion. What kind of energy? Well, a match will give you it, or a grill lighter. What do you need? Heat energy. Okay, and your end results are a flame, water vapor, carbon dioxide gas as well. And this type of reaction is also, I feel some kind of heat energy coming off of that. So it's an exothermic reaction. Thermometer, temperature, heat energy. Exo, what does that mean?
Exits.
What do you do when you exit?
You go out.
Adios, leave. Adios. Ex-girlfriend, ex-wife, ex-boyfriend, ex-whatever. So it's leaving, all right? So it's heat energy leaving this reaction. All right, so what kind of things are combustible?
Lots.
Well,
Firecrackers.
firecrackers, of course.
Fireworks.
Nukes.
Paraffin, candles,
Explosion.
paper, wood, gasoline, things, you know, sometimes things are combustible that you wouldn't think are, depending on what state they're in. I'll show you what I mean. Now, in this watch glass, I have some yellowish powder called lycopodium powder. It's also known as flash powder. If you watch a magician work, sometimes they'll load this up in a ring to have flames come off their hand. It's actually an organic material. It's the spore of a fern. Kind of like, the lime green pollen you'll see in a couple of months. All right? Let me put a little bit of this heat energy and combustion to this little pile of lycopodium powder, so we'll see what happens. Not too much, a little fizzle. I'm going to take the same powder. I'm going to use my little turkey baster here. I'm going to load it up. And I'm going to shoot some across this flame. Let's see what happens.
What?
Should I do it again?
I did. I'm taking a video.
I knocked my flame out.
Can you?
Taking a
All right, one more shot.
Dude, take a picture. When it's
Have a seat. You're in my flame direction. Everybody have a seat. I didn't know it was going to be on YouTube tonight. All right? Here we go.
I got it.
Lights, please.
Could you take it on a picture?
No, it's too hard to take a picture of that.
Now, hey, there's a little watch glass of it. I didn't even see a flame come off it. No, a 2-footer right there. Why in one instance did I get a lot of combustion, in another I didn't get any?
You put it on.
What do you say? Oh, I guess thinking. You said in the right track. Any other? Hey, let's look at this. What do you need again? You need oxygen. And in this watch glass, you only have maybe 3 square inches of surface area for oxygen to be involved in the chemical reaction. Most of the lycopodium powder is buried beneath the pile. But when I airborne or aerosol the powder, every little grain is now exposed to have combustion. So by increasing the surface area, I was able to have more combustion. I don't want you to try this at home, but I could do the same thing with baby powder, cornstarch. A lot of things you wouldn't think would be combustible when in a certain presentation can be. That's why sometimes you'll read in the news, it happens frequently, a grain silo might explode. Or there was a sugar factory explosion a couple years ago in Georgia. When they do their wheat run in the late summer, it happened this year, I saw it in the news, and a silo exploded, and I think it obliterated a couple people. Even dust from wheat or corn, if you get a static release of electricity, there can be an explosion. So they have to be aware of that. So some things can be combustible that you wouldn't think. Now, what color's that flame? Yellowish, got a little blue to it. Okay. A qualitative observation. Okay. One person's yellow is another person's orange. Well, one thing chemists can do, and actually astronomers, is look at the flame test. A flame test, the color of a flame of a material that is producing a flame. And they can kind of figure out what may be in it, based on what we know in the periodic table. So right here, let's start with, I have some sodium chloride, calcium chloride, potassium chloride, copper chloride, strontium chloride, lithium chloride. 1, 2, 3, 4, 5, I can't count. 6 different compounds. What do they all have in common?
Chloride.
The chloride ion. What's different? That's our constant. What's our independent variable here? Calcium, potassium, sodium, copper, strontium, lithium. Those are all, actually they're all metallic ions. So what I'm going to do is add a little methyl alcohol to each one to help them produce a flame. And we're going to look at the color of the flame and see if it's different between these products. All right, I'm going to, just to save a little time, I'm going to pull alcohol on the sodium chloride, calcium chloride, and potassium chloride. Sodium chloride, anybody know what's a more common name for that?
Salt.
That's your typical table salt. Calcium chloride, probably haven't had much chance to use it this year, but that's rock salt. Why would you throw rock salt out on the ice? To lower the freezing point of water, because salt water will freeze, but it's got to be below 27 degrees or so. And potassium chloride, well, you can buy that at Kroger's or something like I did. For whatever reason, some people, that's better for their hypertension or blood pressure. It's just a salt substitute. It's not calcium chloride. It's not sodium chloride. It's a different kind of salt. All right, so lights, please. Let's put a little flame to these puppies and see what we got. Now, when you see blue, that's the alcohol burning. Do you see a particular change in difference in color between the 3 flames?
It gets like orange. It's like one's orange, one's more.
I don't know about you guys, but this one maybe is a little more orange. This one's a little more pink. This one's a little more. Guys, you got to stay in your seat.
Down, guys.
All right. That's why I'm wearing my protective gear. You're not, so I don't want stuff to spill on there. All right.
There's only one.
So not too big of a difference, right? No big what? Yes.
did.
Doesn't orange mean it's carbon dioxide?
It could be. It could be. You have lights in your gym, they're kind of yellowish? Or the lights you see out in the parking lot are kind of yellowish sometimes?
Yes.
Sodium lights, the sodium chloride, all right? Sodium tends to give you that yellow color. All right, let's copper chloride. You put a little alcohol in there.
I need.
Let's put a little heat energy to it. And stay in your seat, guys. I don't want you running out here. You're going to have to use your zooms or whatever you got on your equipment out there. All right, so I put a little bit extra alcohol in there, but what color are you seeing now?
Oh my God, no.
Not bad.
What? Never saw green flags. I know.
Now you have.
I'm taking a video, and this has been 8 hours.
So, when a scientist is doing a flame test on material and you see some green, perhaps you've got some.
Copper chloride.
And if you know anything made of copper, that especially when it tarnishes, that's not surprising, all right? What's happening? Well, when you add heat energy to these atoms, electrons start jumping between shells. They'll go from a lower to a higher energy state. And like people, if you're running around like a maniac, eventually you're going to run out of energy and calm down again. So those electrons, when they gained energy and they go back to a more stable state, that energy is released as light energy. Every atom has a different color because of that. Okay, here's my last two, strontium and lithium. Forget which one is which here. We fire up these guys.
Please be green.
Yes.
Red.
I didn't get any alcohol. Can I have the lights, please, for a second? Yeah, I should have soaked them before we went. Okay. Lights, please. All right. All right, I dumped a bunch of alcohol in there. Any difference between those two colors?
One is orange and blue, the other is like red.
For me, again, this one's a little more orangey red. This one's a little more magenta, purplish red. So again, the scientist can use a flame test to try and determine what may be in an element. Okay, lights. Well, that's kind of fine and dandy, but maybe you have seen colored lights before from flame tests. Well, correct me if I'm wrong. About once a year, you get in the car with your brothers and sisters, you go drive into traffic, it takes you 3 hours to get there, you get out and you look up in the night sky, watch the show, get back in your car, 2 or 3 hours later, you get out of there and you go home. What do you see up in the sky on July 4th?
July 4th.
The people who put together pyrotechnics know exactly what compounds and elements they're putting in for a particular effect. So it's definitely used in that. Flame test. Actually, the light energy getting off that element is also used by astronomers to try and figure out what may be in planets' atmospheres. The light energy coming from a star behind a planet kind of cuts through the rim of a planet, and they got special filters on these telescopes to try and help them figure out what might be in there. All right, so that's combustion. Okay, pH is next. pH is analytical, it's a numerical, it's a concentration of a particular hydrogen ion, and it tells you something if it's an acid or a base. Okay? You guys are, and the scale goes from 0 to 14. 7 is not an acid or a base, it's called neutral. Anything less than 7 is an acid. The lower the number, the stronger the acid. Anything greater than 7 is a base or an alkali. You guys ever drink acids?
Yes.
You probably do every day.
I ate soda.
What kind of acid's in lemonade or orange juice or apple juice? Citric acid. You ever eat anything that's got vinegar in it?
Yes.
Acetic acid. All right? When you drink some acids like that, what does it make your mouth do? Especially, say, like lime or lemon juice.
Sour.
Yeah, it makes you kind of pucker up, okay? There's stronger acids, of course, than that. Heck, the acids in your stomach have a pH of like 2.5. That's real strong. That helps with your digestion. So you got a mucus layer in your tummy to kind of protect from burning a hole in your stomach. All right, bases. Hopefully you're not drinking too many bases, because a lot of cleaning products are alkalis, like lye, a lot of household chemicals and like ammonia and stuff like that. But you may take an antacid if your tummy's upset, like Pepto-Bismol or something like that, okay, to neutralize it. Your drinking water is somewhere around 7. It's probably not right on the nose, but hopefully it's somewhere right around it. So how do we determine if something is an acid or a base? We're going to conduct a pH test. Woohoo! Makes sense, all right? Now, one way you can do it, of course nowadays, when you're in the lab, there's probably all kinds of digital equipment. You stick a probe in a liquid and you get a number. But here's another way you can do it. I took this tube and I filled it up with water and I put a little bit of this indicator solution in it. It has to be green. I'm going to put 1 drop of sodium hydroxide in there, 1 molar. All right? Now, anytime you see OH, hydroxyl at the end of a chemical, it's a good chance you might have a base. All I'm going to do is take 1 drop.
That can explode.
And
No, it's gonna be a nuclear
put it
explosion.
right.
We close the lights.
We're all gonna die.
Yes,
I didn't mean to hit the glass, but I think it'll still
Nuclear
work.
explosion.
1 drop of that. Always cap your things when you're done in chemistry so you don't accidentally grab the wrong thing. There's some cooking too.
What happened?
Right? Did we see anything happen?
No.
Oh, let's put some more in. Got to see something happening. All right, 1 drop sodium hydroxide. Whoa, what's happening? It's turning. It's actually a very dark purple. So, in the presence of a base, the green turns
Purple.
purple. Okay. I'm going to flip this guy over.
You.
Purple.
And I'm going to put in 1 drop of
Scientific ink.
Potassium nitrate.
1 molar hydrochloric acid. Is that an acid or a base?
Acid.
Yeah, it tells me right there. See, acid. And a lot of times when you see an H in front of a, it's in front of a formula, there's a good chance you got an acid. So I'm just going to put 1 drop hydrochloric acid, 1 molar, right there. That's all I need.
I do that.
Did it change color?
Yeah. It's totally red. Red.
All right. So in the presence of acid, the green turned kind of. Look, you got to sit down. I'm sorry, guys. You got to tell these kids. You can't come up here.
Kids, please sit on your chairs now.
I can't.
Thank you.
Got to stay in your chairs.
There are people behind me.
It's a health and safety. If this stuff breaks out, I don't want it going all over your head. You're going to have to get a picture from
Ali,
afar.
on your chair, please.
I'm going to flip this
Sorry, Ali
over.
wants you on your chair. Thank you.
And I didn't get the greatest representation. In fact, I lost my red. But a lot of times I'll see red to orange to yellow to green to blue, and you get a color representation of different pHs. Not exact numbers, but when you see red, I just didn't put enough acid in, then to orange, then to yellow, it's a weaker acid. Green is somewhere around 7, and then up to purple, it's more of a base. Now, as I said, there's a lot of digital equipment out there to do that now. Or you could do a pH test yourself at home. Why would you do that? Anybody have a pool?
Yeah.
Or if you're a lifeguard, sometimes, how's your pH test work? You dip like the thing in the water, then what do? You add a couple drops of something,
Yeah, it's like
indicator solution, then what do? You get a different color, and what do? I'm looking for one here. Well, anyway, the pH kits come with like different colors and
And it tells
numbers.
you if it's okay to drink it or...
Well, it tells you what the pH is. I don't know where you go from there. I've got a fish tank at home. Sometimes the pH gets out of whack, and if it's too high or low for certain fish, it's not healthy for them. So if it's too acidic, I can put some powder in to make it more basic. Too basic, I put some drops in to make it more acidic, if you know what I mean. So that's pH, okay? All right, what's next? Oxidation reduction. What color is this fluid here? Yellow? Okay.
it's turning green. Or blue.
Purple.
Let me do a little, I gotta do a few dishes here. So what, I gotta get ready for the next group. You guys are coming here.
It turns yellow again.
I thought you said it was blue. Let me shake it up. Come on. Quit pulling my pigtail here. What color is it?
Blue.
Blue, you say, huh?
No, it's
Okay,
yellow.
let's move that
It's
over
gonna turn
here.
yellow again.
And am I done with this? Yeah, I'm kind of doing that. I'll put that
Black,
over there.
dark blue.
Put that over there, and put this over here.
Yellow.
I thought you said it was blue. Alright, what's going on here? It's a little fun way to have an oxidation reduction reaction. This is kind of high-end chemistry a little bit, but oxidation reduction reactions happen all the time. Frequently from gaining or losing oxygen, which kind of changes the amount of free electrons available. That's really what oxidation reduction is, changing the amount of free electrons available off a molecule. So, I happen to put like 250 milliliters of water in here, 8 grams of sodium hydroxide, that's lime, 4 grams of dextrose. Anybody know what a dextrose? Sucrose? Fructose? Types of... Did you guys learn your photosynthesis?
Yeah. Yes.
Is that ringing a bell? Sucrose? Sugar? It's
Yeah.
a type of sugar. And I put a bunch of drops of this blue indicator solution in. Now, when I shake up this fluid, oxygen in the air dissolves into the solution. The indicator solution bonds with the oxygen. When the oxygen comes in, it's less free electrons. And then, as the fluid sits here, it's apparently a weak bond. The oxygen is released right back into the air, freeing up more electrons. And it just gives like a little fun way to have colors change. It's based on how the indicator solution is either gaining or losing oxygen. That's what oxidation reduction reactions are. Didn't we see an oxidation reduction reaction when we first started out? Well, what do you need in combustion? Oxygen. It just didn't disappear. It chemically bonded with whatever is left over, okay? Or it wound up in the carbon dioxide or water vapor. Or rust. How do you get rust? Leave your bike out in the rain. What happens? Combines with iron. Iron oxide, okay? Oxidation reduction. Okay. Before we get to our catalyst, we talked about an exothermic reaction, right? So it's a loss or release of heat energy. Well, I've got a little pile of some powder here. Which one was this one called again? Not that one. This is ammonium chloride. Now, what I'm going to do is, if you could, just kind of feel this with your fingers. And tell me, is it relatively warm or cold, based on how your hand feels? Room temperature?
Yeah.
Okay. All right, that's cool. All right, all I'm going to do is add
It doesn't feel like anything.
a little water.
It feels dust.
All right? So let me get a
Can you do it for now?
quick squirt of water here. I'm going to pour it in. Actually, I'm going to add more than that. I'm going to add a little more than that. I'm actually pour it in. I think that's good. So I want that stuff to kind of dissolve. Doesn't take much water. Now, if you could feel that for me.